So, M&M's, which is not a chocolate, but it is also, well, it is a chocolate, but it's also frequently referred to in the finance literature as M&M. And these two individuals really are the godfathers of modern corporate finance theory. They published papers in the late 50s and early 60s that really changed the way that CFOs, corporations, and organizations of all types think about debt and how to act on debt. Because before them, we really had no idea about what were even the relevant factors in deciding capital structure decisions. So M&M brought a conceptual framework that really has helped us better understand why managers do what they do. So we're going to go through their models, and I'm going to go through them slowly, as you requested. And because it's difficult stuff, and don't feel like I'm asking a dumb question, because there isn't a dumb question when it comes to this, stuff, because it is difficult. So they start off with a series of assumptions which are very simplifying, because always in finance you have to start in a simple world in order to then extrapolate into a more complicated world. And I'm not going to go through all these, you can just read them. So the first proposition they came up with is that in a world without taxes, then the value of the levered firm, and levered means with debt, is equal to the value of the unlevered firm, which is without debt. So basically, debt doesn't matter. And we'll go through that in a second. And then the second proposition is that the required rate of return on equity for a levered firm, in other words, if you're a firm that has debt in it, then the equity holders will know that they've got debt in your capital structure, and they will adjust the amount they require for the rate of return based on how much debt they've got, the firm has in its capital structure. Why do equity holders care about the amount of debt?
Because there's more risk.
There's more risk. As soon as you introduce debt into a capital structure, you are introducing financial risk. And the more debt you introduce into the capital structure, the riskier becomes the organization, and therefore the riskier becomes the income flow to the equity holders. So equity holders care a lot about the amount of debt that any particular organization has. And so what their insight was is that the required return on equity for a levered firm is equal to the required rate of return on equity of the unlevered firm plus a risk premium. And this risk premium is the amount of extra return they require because the firm has decided to have debt in its capital structure. If the firm had no debt in the capital structure, and the required rate of return on the levered firm would be the same as the required rate of return on equity of the unlevered firm. But as soon as the firm decides to introduce debt, investors will yank up or lever up their required rate of return on that because they know that that will cause the firm to be riskier than it would be without debt. The key is this ratio here, the D over E. So what they thought was that the required rate of return on equity of the levered firm, the required rate of return on equity of the unlevered firm, plus this risk premium, and this risk premium goes up in a mathematically precise fashion. Goes up according to the amount of debt in the capital structure. So as D gets higher, as the amount of debt gets higher and higher and higher, this risk premium gets higher and higher and higher. So if a firm has got 20% debt in its capital structure, it will require a certain amount of, the equity holders will require a certain amount. If it goes to 60%, the shareholders will require a much higher rate of return because there's a huge increase in the amount of debt, which represents a huge increase in the amount of equity. Any questions about this slide? Okay, So we can graph this, because M&M is, I think, easier to understand when you look at graphs. What this essentially saying is that because this world has no taxes, and the value of the firm is independent of the amount of debt it has, there's a constant required rate of return on debt, that's just the interest rate that's charged. The required rate of return on equity goes up with the amount of debt, but it goes up at the same proportion as it goes up at a rate that is exactly equal to the offset in the lower cost of the risk of the required rate of return on debt. In other words, the required rate of return on debt is lower than the required rate of return on equity. It's a cheaper source of capital. So as you get more and more debt in the capital structure, the cost of equity goes up, but it's offset by the fact that D is increasing, and D consists of cheaper capital. So the cost of equity is going up, but the proportion of equity is going down. In other words, the proportion of debt is going up, but the cost of debt is lower. And those two are exactly offset so that the corporate cost of capital remains the same no matter how much debt is used.
Can you say that again? What you're saying about the cost
Okay,
of
so
equity going down?
debt is cheaper than equity. As equity, as the proportion of debt. So as an organization increases the amount of debt, the required rate of return on equity goes up because equity holders get worried about the riskiness of the firm. That's what this line is here. However, the corporate cost of capital stays the same across all levels of debt, because although this is going up, the cost of equity is going up this way, the proportion of equity in the capital structure is going down. This is D over E. This is the amount of debt. So as we go from here to here, the proportion of equity in the capital structure is going down, and the cost of equity is going up. And that rate exactly equals the proportion of debt going up, but the cost of debt being lower. So as you're going from here to here, you're getting more and more cheap debt, but you're getting higher cost equity. And those two exactly offset each other. That was their insight. At least that was our hypothesis.
The cost of debt is going down or it's remaining constant?
Cost of debt is constant.
See, one word you said rate exactly equals proportion of debt going up. I missed the second part.
Say the cost of debt, the corporate cost of capital, as we learned last time, consists of the weighted amount of the cost of debt and the weighted amount of the cost of equity, right? So as we go from zero debt to, say, 100% debt, the proportion of debt in the capital structure is increasing, but the cost of debt is cheap. So you would think the cost of capital would go down, right? More and more cheap capital you have, you would think the corporate cost of capital would go down. But as you're going from here to 100%, the cost of equity is going up. And that is enough to exactly offset the decline from having cheaper debt. One more time?
Yeah.
Okay, so we've got zero debt over here. Let's say we've got 100% debt over here. The most important point here is that the corporate cost of capital is staying the same across all levels of debt. And so why is it staying the same? Well, we've got two components of the corporate cost of capital. We've got the cost of debt, we've got the cost of equity. So you would think that by starting over here at 0%, if we had going up to 100% debt, you'd think the corporate cost of capital now would sort of edge down because we have more and more of our capital structure is cheap debt. But in fact, as we add more and more debt, what the M&M are hypothesizing is that the cost of equity, it goes up because equity holders are concerned about the risk of adding debt to the capital structure. So the benefits from going from 0 to 100%, the benefits of more cheap debt are exactly offset by the costs of increased equity. Is that clear? As you go from 0 to 100% debt, the benefits of having more cheap debt are exactly offset by the costs of increasingly expensive equity.
And you know that because your corporate cost of capital stays the same?
The corporate cost of capital stays the same if you believe that relationship.
Okay.
Okay, so in the mini case today, you're going to actually calculate the numbers that go into this graph. And I think light bulbs will go on when you calculate this number and this number and this number and this number, and why you're getting those numbers. He says confidently. So what do we conclude from M&M without taxes? In a world without taxes, essentially, the equity becomes riskier as you add more and more debt, but the cost of capital stays the same because the benefits of increasing the amount of low-cost debt are exactly offset by the increase in the equity cost. So the bottom line is, it doesn't matter. The value of the firm is unaffected by the amount of debt that it has in its capital structure. So M&M, 1958, said, everybody's been worrying about how much debt we should have in our capital structure. Forget about it, it doesn't matter. And of course, there was almost a call, a unanimous shout back, you've assumed no taxes. And in a world like that, you're right. But who lives in that world? Not us. Maybe Monaco, Cayman Islands. They're the only few countries that don't have taxes. So as a result of the criticism, they spent 5 years thinking about how do we introduce corporate taxes into our naive model of the world. They sound like slow thinkers. They're really smart people, let me tell you. So after 5 years, they revised their original model and said, in fact, the value of the levered firm, the value of the firm with debt, is equal to the value of the unlevered firm, which is the firm without debt, plus the tax shield, the tax rate times the amount of debt. Now, you may ask, why TD? In fact, it really is the rate of return on debt times the amount of debt, which is the amount of the interest expense per year, times the tax shield, times the tax rate. But because M&M assumed that all cash flows are perpetuities, you have to divide that by RD. So the two RDs cancel out, and you're left with TD. So essentially, D is like the amount of debt, $500 million, whatever, and T is the tax rate. So we'll follow this through in a second, but for now, this is what I'm asking you to accept for the second. That the proposition with taxes and with corporate taxes is that the firm with debt is equal to the firm without debt plus the value of its tax shield of the debt. They then had to had to edit their original proposition 2, which again, this is all the same now. This is exactly the same as the first model, except now they've put in a 1 minus T model term, which is 1 minus the corporate tax rate. You still have the D over E, but now we're multiplying it by 0.6, 0.7, 0.8. And what does that do? Well, now what we see is that the corporate cost of capital starts to come down. As I mentioned a few minutes ago, why wasn't it coming down? And the reason it's coming down is there isn't the benefit, the benefit to debt isn't as great as it was in a world without taxes. Because this RRD is now being multiplied by 1 minus T. So in fact, what happens now is that the cost of, let me put the slide up here. So when we add taxes to the model, the value of the levered firm increases And the greater, and just like before, the greater the amount of debt, the higher the value of the firm. But the cost of equity increases at a slower rate because of the 1 minus t firm. So the cost of equity in the first model went up very quickly, and the second model does not go up as quickly. So the implications of that, essentially, we calculated a minute ago in the first model, the value of unlevered firm was a straight line across. What the second model shows is that the value of the levered firm essentially is the value of the unlevered firm plus the tax shield, the TD. So what would you say? Where's the best value? Where's the optimal value of the firm here? What's the optimal debt level?
You should have 100% debt.
That's right. You said 100% debt. That's that line right there, 100%, because that's where the value of the firm is highest. So M&M switched entirely from their 1958 model where they said amount of debt doesn't matter, and then their 1963 model where they said, in fact, firms should finance entirely with debt because there's a tax shield to debt and there's no tax shield to equity. I will stop. Go back. So again, this is the same graph as before, except now the corporate cost of capital is coming down because the cost of equity isn't going up as fast because it's being multiplied with this 1 minus t rate that's been introduced into the required rate of return on debt. So now it means that, in fact, it's optimal for the firm to have 100% debt because there's a tax shield to debt and there is no tax shield to equity.
Just to be sure, the value of the levered is 100% debt and the value of unlevered is 100% equity. Like they don't represent a 50-50 mix. It's just one or the other.
Now, the 50-50 mix would be here. There's zero debt. That's all equity.
Okay.
This is all debt.
Okay.
And 50-50 would be here somewhere. So they decided then that life wasn't complicated enough. So Merton Miller then spent 24 years thinking about how to revise the model to include personal taxes. So what he said was, in fact, because the rate of tax on equity to personal investors is less than the rate of tax on debt. So when you get interest income, you face a much higher tax rate, marginal tax rate, than you do when you get dividends. And then the corporation also has its corp tax rate that it pays. So he developed this model, which again is the same as before, except which is the value of the levered firm is the value of the unlevered firm, plus this tax shield. This is just a much bigger, more complicated tax shield. And what he's saying is, of course, is that if E and D are the same, and this just collapses to what? These two, if you take those two out.
Just to the tax shield of the corporation.
Right, it'll collapse back to this model. That's if there's no difference in taxation rate, if investors face no difference between equity and debt, they pay the same rate of tax on equity income as they do debt income, then this model collapses to the original model. But it's because investors pay different rates of tax on equity and debt that the model doesn't produce the same results. So here's just a simple arithmetic example. If the corporation pays tax at 40%, and the tax on interest income is 30%, and the tax on equity income, dividends, is 12%. You do the arithmetic. In fact, you then find the value is 0 BU plus 0.25B, which means it's the value of the levered firm is the value of the unlevered firm plus 25% of the value of the debt, the face value of the debt. So how does that compare with our original model? Well, we had a 40% tax rate. So in the original model, the second model with M&M, You had VL, value of loaded firm, is the value of the unloaded firm, plus 40%, which is the corporate tax rate times the debt. So by introducing personal taxes into this model, Miller said, yes, there are benefits to debt financing, but they're not as great as what we thought they were. The reason is because investors pay different rates on tax for equity and debt income. So in the original model, it was 40%. Every extra $100 of debt raised the value of the firm by $40. In Miller's model, it only increases the value by $25. However, what does this equation say about the amount of debt that should be in the capital structure? It's not 0.4 anymore, it's only 0.25. What does it tell managers to do? How do you maximize VL?
By maximizing the,
Sorry?
by maximizing your debt.
It's the same advice, isn't it? He said by maximizing the debt, and that's right. The value of the tax shield isn't as great as it was before, but it still tells you to 100% debt financing. So even after introducing personal taxes, the advice from Miller was still the same.